Hey guys, we're going to be looking at our second lesson, which is working with one or two categorical variables. So to summarize a categorical variable, we want to count how many individuals fall into each possible category. Percentages usually are more informative than counts, but we'll work with both. So here is data, seatbelt use by 12th graders. One of the questions in a 2003 national survey asked, how often do you wear a seatbelt while driving a car? Possible answers for the seatbelt questions were always, most times, sometimes, rarely, or never. So 5 different categories. Respondents could also say that they didn't drive. So a total of 3,042 seniors were asked, and here are the different counts. So 1686 said always, most times 587, etc., etc., etc. When we have tabular data like this, it's good to look at, we want to get some sort of a visual. So we can look at a pie chart or a bar graph. So we're actually going to enter the seatbelt data into stablet.com under one categorical variable, a single group. This is one of the apps that you guys will work with this semester. You'll have access to it during tests, so you want to be familiar on how to work with it. So let me go to here. So we want one categorical variable, single group. So this is, we're going to call this seatbelt usage. And I'm actually going to pull up the data on the side. So my category types are always and 1686, most times 578. I'm going to add a couple categories. For your first assignment, you will want to do a few of these. Sometimes, rarely, never. Sometimes is 414, rarely is 249, and never is 115. So we're going to begin our analysis. So here is a bar chart, and you can see the different magnitudes including the counts. I can have frequency, which is just the raw number of counts. So for example, 1686 is how many people responded as always. I can also change it to relative frequency, which now gives me percentages. So 55.4% said always, 19% said most times, 13.6% said sometimes, etc., etc., etc. So here's the relative frequency table. Categories, frequency, or relative frequency. I can also change it into a pie chart. And same idea, I can hover over a section. So for example, if I want rarely, rarely is the peach one, and my percentage here is 8.2%. So as part of assignment number 1, you'll want to recreate a bar chart and a pie chart, and you'll want to include that into your assignment number 1. So the survey also asked, what is your sex? And the response options were female or male. So we can take this sample data of 3,042 students, and now we can divide that by gender. One stereotype about males and females is that males are more likely to engage in risky behaviors than females are. This is true. So now we have seatbelt usage by 12th graders. It says table 2.2 summarizes seatbelt use for male and female 12th grade students in the sample. So we want to know if there's a relationship between someone's gender and the frequency of wearing a seatbelt. So we want to enter the male and female seatbelt data into Stapplet.com. So now we've got multiple groups. We still have a one categorical variable, and now we're dealing with multiple groups. We want to make a mosaic plot and a side-by-side bar graph of the two. All right, so I'm going to show you how to do this. Let me see if it pops up. So here I'm going to do one categorical variable, multiple groups, and I will have 5 different groups here. So always, most times, sometimes, rarely, and never. And I'll have female 915, 276, 167, 84, 25, male 771, 302, 247, 165, and 90. So variable name, this will be gender. Begin analysis. So the two things that I will want you to include in your assignment number 1 is our mosaic plots and side-by-side bar graphs. So let's start with a side-by-side bar graph. So let's do just general frequency. So you can see that for females, there are it's the only category that is greater than males. Although we've got different. There's more males than females, and in spite of that, more females always wear their seatbelt compared to males. Now, if we look at relative frequencies. So for relative frequencies, these two things add up to 100. So you can see, overwhelmingly, out of all the people who never wear a seatbelt, there's like essentially 4-to-1 males to females in terms of people that don't wear seatbelts. And for every category other than always, basically, males don't wear seatbelts much more frequently than females do. All right, let's look at a mosaic plot. So a mosaic plot looks at areas of things. So basically, the bigger area, the higher the percentage of something compared to the whole. So you can see the female never is a very small percentage of the total sample size, and the female always, it's the biggest area. So you can see the male always, female always, the female always is just a little bit bigger. So include both of those charts, recreate them, and include them in the in your assignment number 1. All right, summarizing 1 or 2 categorical variables, frequency and relative frequency. A frequency distribution for a categorical variable is a listing of all categories, including their counts, and a relative frequency distribution, basically instead of counts, you have proportions or percentages. So it's commonplace to give frequency and relative frequency distributions together, which kind of makes sense. You kind of have the raw data, and then you have the percentages to give you some perspective. So in this case, when we have, we put our raw data in, and we've got a summary statistics. So we've got females, female always, female most times, and it looks at the percentages. So like each of the always categories add up to 1. So for always, out of the always, 54.3% are female. Out of the always, 45.7% are the males. For the never, 78.3% are the males, and 21.7% are the females. Our second example, we have a survey of 479 children, and it looked at those who slept with a nightlight versus those who slept in a fully lit room before the age of 2, and looked at the incidence of nearsightedness. It's pretty wild to think about having a kid sleep in a fully lit room. So just kind of curious how that goes down. So the raw data is here. We've got myopia, no myopia, and high myopia, which is nearsightedness. And we're looking at the relationship between sleeping in darkness, sleeping with a nightlight, and sleeping with full light. So we talked about having explanatory and response variables. And in this case, we want to look at the relationship between, do we think there's some sort of an effect of light on potentially myopia down the line? In many summaries of 2 categorical variables, we can identify one variable that has a effect on the other. Let's analyze the data by making a side-by-side bar graph. Again, this is on Staplet. We can put the data in, and we're looking at what effect sleeping in darkness with a nightlight or full light has on either no myopia, myopia, or high myopia. So this is not slept with, but developed. So the two options are a frequency graph and a relative frequency graph. So with a relative frequency graph, you can see the percentages between the different categories. So for example, each of these, so for darkness, all 3 of those add up to 100%. And same with full light. So the nice thing is you can see, for example, so for full light, when someone slept with a full light, roughly 45%, somewhere between 40 and 50% developed myopia. And roughly like between 5 and 7% developed high myopia. So it does seem that for those kids who are before the age of 2 were sleeping in a room that had full light, it does seem like it had an effect on developing myopia, even with a nightlight. Seems like those are higher than sleeping in full darkness. We can talk about why that is, but for now we just want to look at the fact that there does seem to be something there, which I think would warrant further investigation. We can see that the amount of sleep, as the amount of sleep time light increases, the incidence of myopia also increases. However, the study does not prove that sleeping actually caused myopia in more children. This is true because, if it did, then these would be significantly higher. Like there would be no kids with no myopia that were raised in a full light sleeping environment. So there's other possible explanations, and this is something that we'll talk about when we talk about experimental design. If we wanted to actually prove that sleeping in a room with full light causes a higher incidence of myopia, then this would be, I think, a fairly unethical experiment, but this is something that if we set up an experiment to do it, then we could actually say that one thing causes the other, like the amount of light caused myopia. But for now, we don't know. We can just, it's some sort of potential correlation, some sort of association, and We can't say that one thing caused another, but there is something going on here.